Alright, now that we have defined absolute maxima and absolute minima, it is pertinent to also define local maxima and local minima. Suppose I is an interval on which a function f is defined and c is an interior point of I. If fc is greater than or equal to fx for all x in some open interval containing c, then fc is a local maximum value of f. Suppose g is a small interval which is a subset of the total interval on which the function f is defined. If the value of the function at the point c is greater than or equal to fx for all values of x only in the interval g, then you can say that the function has a local maxima at x is equal to c. If the function similarly has fc less than or equal to fx for all x in some open interval containing c, then fc is a local minimum value of f. Again, if we assume that g is a sub-interval of the total interval in which the function is defined, and then if the value of the function at the point x is equal to c is less than or equal to fx for all values of x in the interval g, then the function has a local minimum value of fc. That is, it is said to have a local minima. However, it is very important to note one important difference between local maxima and local minima, apart from the obvious differences, and absolute maxima and absolute minima. And that is the fact that even though absolute maxima and minima can occur at endpoints, local maxima and local minima do not have that luxury. Local maxima and local minima always happen between the intervals in which the function is defined, not at the endpoints as given here. Local maxima and minima occur at interior points of the interval of interest, not at endpoints. It's a very important point to remember. Alright, let's look at example 2 to identify local maxima and minima as well as absolute maxima and minima. We have been given the graph of some random function and some important points on the graph of this function have been marked. We have to identify which are the local maxima and minima as well as absolute maxima and minima. First, let us consider the highest point on the graph of this function. The highest point occurs at x is equal to e. That is the point which has the highest y coordinate at x is equal to e. So therefore, this point would be the absolute maximum value of the function. Absolute maxima occurs at x is equal to e. Let us look at the lowest point on the graph of this function. This occurs at x is equal to a. Therefore, at x is equal to a, the function has an absolute minima. And now it is time to consider other points which are given in this graph. Consider the point x is equal to c. The point x is equal to c is a local peak because if you consider a small interval of interest to the left and right of c and you draw the corresponding y coordinates, then you would see that f of c is the maximum value in that particular interval. So this particular interval that we've drawn to the left and right of C could be counted as an subinterval of the given function. So therefore, x is equal to C becomes a local maxima. And similarly, x is equal to D becomes a local minima. Okay, what about the point x is equal to b? Can we say that it is a local minima? No, because x is equal to b is an endpoint of the function, and at endpoints we are not allowed to define that point as local maxima or local minima. So therefore, x is equal to b is neither a local maxima nor a local minima, nor is it even an absolute minima, because absolute minima was obtained at the point x is equal to a. Note, however, also the fact that the absolute maxima of the function can also be called the local maxima of the function, because to the left and right of the point x is equal to e, if you draw a small subinterval of the function, then x is equal to e correspondingly also becomes a local maximum value. It is the highest point even in that subinterval. And similarly, at the point x is equal to a, you cannot draw a similar conclusion, because again x is equal to a is a end point of the graph, or it's a starting point of the graph, and starting point of the graph cannot be classified as a local extreme value. That is, it cannot be called a local maximum or a local minimum value. Therefore, even though it is absolute minima, it cannot be called local minima of the function.